here. So we are going to see the first lecture in a series of digital principles and system design. So in this series we are going to cover this 5 units. So today we are going to see review of number systems. So in this one number system we'll have 3 lectures. So where any base to decimal, and lecture 2 is decimal to any base, and lecture 3 is any base to any base. So in any number system, the digits of a numbers has 2 parts. One is integer, other one is going to be your fraction. So how to represent this number is, so from A1 to AN, where A1 is said to be your LSB, that is your least significant bit. And AN minus 1 is said to be your MSB, which is called as a most significant base. So this is your integer part. And this is going to be the fraction part. After your decimal point, A minus 1, A minus 2, it goes for A suffix m. So a radix or base, if a number system is going to have a radix or base of r, then it is going to have n r number of unique digits here. So including your 0. So if your number is represented by any radix or base, it's going to be a0 into r0, a1 into r1, it goes on till your an into r power n. So this is your LSB, this is going to be your MSB. And this is the integer representation, and this is going to be your in a fraction representation. Suppose if your number system is going to be binary with a radix of or base of 2, it is going to have two values, so 0, 1. If it is going to be octal with base 8, then it is going to have 8 values, 0 to 7. Then if you are going to have a decimal of base 10, it is going to have 10 values from 0 to 9. And if it is hexadecimal, it's going to have 16 values, that is 0 to 15 here. This is how it works. So this is going to be your radix or base, and this is going to be, it has unique numbers here. Now we are going to see the procedure how to convert any base to decimal. First is expand the number in a power series by multiplying each digit in the number by its positional weight, and add all the terms. We'll have an example for this one. Convert this binary 1101 is going to be a binary. So from we are going first one, we are going to convert this binary into a decimal. So expand this in the power series. For this easy method, I'll have this one, and then I'll have the expansion of this one, right? So this is going to have this 1, this 0, 1 and 1. So now we don't have any fraction part, only we have your integer part. So it is going to be a power series multiplying each digit. So this is your digit in the number by positional weight. So what is this positional weight? Now what is the base or radix of this one? It's going to be 2. So this is going to be 2 power 0, 2 power 1, 2 and 3. This is your positional weight. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 1 into 2 power 0 is 1. To anything power 0 is going to be 1. So 1 into 1 is 1. Then next second weight is 2 power 1. So 0 into anything is going to be 0. Next is position is 2 power 2. 2 power 2 is 4. 1 into 4 is 4. And next is 2 power 3. 2 power 3 is 8. 1 into 2 power 3 is going to be 8. So next second step is to add all. 8 plus 4 plus 1 is going to be 13. So it's going to be 13. So this is your answer. We'll have some more examples here. Convert this one. So here this is going to have the base 4 and then convert it to a decimal. So whatever it may be, first one you have to write it in terms of power series. So here the base is going to be 4. So positional weight is 4 power x positional weight. So I am writing this 3102.12. So this is going to be your integer and this is going to be your fraction here, right? So integer, I am going to write its corresponding bit here. So it's going to be 212013 here. So now integer will complete it out. So here it's going to be your integer part. So it starts from the 0. Position is going to be, this is the 0th position, first position, second position and third position. So it's going to be 2 into 4 power 0 is 2. 0 into 4 power 1 is 0. 4 power 2, 16. 16 into 1 is 16. And 4 power 3 into 3. So the value is going to be 192. So after this, I'm going for the fractional part. So fractional position is, so this is going to be minus 1 and minus 2. So it's going to be 4 power minus 1, which is equal to 0.25. 4 power minus 2 into your 2 is going to be 0.125. Now add all the values here. So this is going to be 5, 7, 3 and then integer part. Now 6 plus 2 plus 2 is going to be 10. So 1 plus 1 is 2, 2 plus 9 is going to be 11 and 1 plus 1 is going to be 2. So it's going to be 210.375 base 10. Convert this hexadecimal value into a decimal. Same thing here. You are going to write the values and then you are going to write it in a power series method. Here the base is going to be 18. So 16. So 16 to the power of the position here. So the position is going to be 0, 1 and 2. Here it's going to be after decimal it's going to be minus 1 and minus 2. So multiply, write it corresponding 16 power 0, 16 power 1 and 16 power 2. I have wrote the value and 16 power minus 1, 16 power minus 2. Now sum all these things, you will get your answer here. This is going to be 6, 1, 9 and then 0. Sorry. So this is going to be 6 and remainder is going to be 1. So the value is going to be 0 and then it's going to be 1. And then here it's going to be point. So it's going to be 6 plus 10, 12 and then it's going to be 8 and it's going to be 4 and it's going to be 2. So it's going to be 2482.109. So this is the practice problems for the practice. Convert this octal base 5 and base 2 into a decimal. And here another one hexadecimal value to your decimal. So these problems are for practice. Thank you guys. Subscribe my channel for automatic. Have a nice day.